Alright, hello and thank you for having us. My name is Todd Wagner and I am the Project Manager and Water Resources Engineer for Vector Associates. Today we're gathered here to discuss our progress on the development of the Crown Point Business Park. In order to effectively communicate our progress, we have broken up today's discussion into 6 different categories. First, I'm going to give a brief overview of what the project is. What does the client want to get out of our design services? Then each one of our design engineers is going to have an opportunity to speak about their progress on this semester. And finally, we're going to have a period for a conclusion and questions for anyone interested. Okay, so first thing, what is the project overview? The client is looking to develop an agricultural lot into a mixed-use business park. Now this business park is going to have a structure somewhere on a parcel, and then we need to develop a roadway to allow access for that structure. In addition, we need to take careful consideration to make sure that water that falls on the parcel is discharged in a clean manner, and we also want to make sure that the roadway has adequate flood prevention techniques. I would now like to hand it off to our transportation engineer, Leah.
Thank you, Todd. As Todd said, my name is Leah, and I am the transportation engineer with Vector Associates. I want to remind you all of my scope and what I have completed since our last progress presentation. So I was first tasked with getting the parcel from the plot of land. So we had about 52 acres of land that we were developed into one parcels, and our parcel's just under 2 acres at 1.989 acres. And from there, I wanted to access and assess the different roadway uses of the 3 roads that are connecting our plot of land, which is Merrillville Road, East Summit Street, and North Indiana Avenue. And from there, I wanted to develop alternatives for that southeast intersection on how to best rework the traffic when I create a road from Merrillville Road to North Indiana Avenue. And from there, I want to decide what alternative we will be moving forward with. So, as you previously saw, like a month and a half ago, I developed an alignment alternative, and I decided to go with the alignment from Merrillville Road, which is on the westward side, to over here, which is North Indiana Avenue, because it did not intersect with any of the railroad tracks or pre-existing utility lines under this, on the south portion of the land. And from there, I had 3 alternatives, and today I'll be diving deeper into my alternative called separation and combination, currently, to remind you, existing at the southeast corner of our parcel, which is down here, of the intersection of East Summit Street and North Indiana Avenue. There's currently an individual right turn lane and a through and left turn lane combined. No, actually turn the other way around. There's a left turn lane and a through and right lane, and at all approaches. And my first alternative is to kind of divide that, so each turn movement, either through, left, or right, creates its own separate lane, and from there, this creates a level of service of C. So as a driver, you'll be waiting no longer than 30 seconds when you get to that light to be moving forward. And this has less land intrusion than my other alternative does. So the property owners nearby will probably like us a little bit more than if we take more of their land. My biggest concerns here would be taking over this parking lot and this parking lot as well. And then my second alternative I want to talk about today is combination, which is kind of combining what's pre-existing and what I just discussed about into many lanes in the east and west direction. The north and south will still remain those 3 separate lanes at the turn intersection, but a combination for east and westbound will have a separate left lane, a through and right lane, and a right lane. If that sounds confusing, it's because it will add a lot of lanes to this intersection. And that also means it will be higher in price, and we will be taking even more land from these nearby property owners. The benefit of this, though, is that we do have a level of service B, so instead of about 30 seconds of wait, you're just a little bit over 20 seconds. So more land for a little bit, 10 seconds saved is kind of the debate right now. So from there, I was able to use the NDOT current pay item list, which is recent as of December of 2024, and find what are the cost estimates. Our alignment from Merrillville Road to North Indiana Avenue costs about $14 million, which sounds like a lot, but if we understand and think back, I had a typical section which had sidewalks on both sides of the road, 5-foot wide sidewalks, and we just know that will be a lot and sidewalks are very expensive. So 14,000 actually is 14 million, my bad. Is not that crazy for the length of our road. And for my two intersection alternatives, we see that the separation one, which uses less lanes and less land, is lower in price for about $50,000, give or take, than the one that adds more lanes. I created a rubric or matrix to figure out what alternative specifically for the intersection will be the best choice. Think of this as like you're taking like a grade. The higher the score, the better. So excellence would be a 3, where like poor, do not want to use it, would be a 1. And from there I chose the parameters of like construction costs, level of service, safety, risk, maintenance over time, how the community is going to ask, and is it practical to drivers and can they understand it. My alternative of separation was significantly better in most categories except for the level of service. As I discussed, combination would save you about 10 seconds, but from that you also will have more maintenance because there's more roads and you will have a higher construction cost as well. Practicality, I felt every approach having the same is more understandable to the drivers than every approach having a little different. So from there, I have chosen alternative separation to move forward, as it had this highest score on my matrix. And from there, next semester, I'm hoping to move forward with that alternative and really dive into like the more transportation related stuff on our parking lot design, the lighting of my alignment, the sidewalk design specifically. All of it right now is preliminary design. And from there, also lighting so that we can light the roads and things like that. I would now like to hand it off to our environmental engineer.
Thank you. I'm Maddie. I'm the environmental engineer for Vector Associates. My scope for this project is to design a gravity flow pavement drainage system for the road that Leah is designing. This includes alternative components for both the inlet structures as well as the conveyance structures that will send the runoff to the subdivision's overall stormwater management systems. For my regulations and standards, I want to minimize spread across the road as well as depth of ponding to maintain vehicle safety. In my previous work, I did preliminary calculations for inlet spacing along the road. This is based on the existing topography of Leah's alignment, but these spacings are subject to change as the final profile of the road is developed and slopes are finalized. So for my collection alternatives, I spoke about grate inlets, curb opening inlets, and combination inlets. At this time, curb opening inlets have been eliminated from final consideration because their interception capacity is not high enough compared to the other two alternatives. For my evaluation, I looked at construction cost, interception capacity, debris handling, and maintenance. So grate inlets score higher for the construction costs because they have fewer components to consider and install. They are more cost effective than the combination inlets. Combination inlets have a significantly higher interception capacity when depth of ponding is high, but at moderate depths of ponding and along the grade, they have very similar interception capacities. Combination inlets also handle debris much better because they have the curb opening component, and they both have similar maintenance requirements. So overall, grate inlets scored 31 versus 30 points for combination inlets. So grate inlets are the selected alternative moving forward. For my conveyance system, my first alternative is a sewer piping network that is going to be in the right-of-way of the road. This is constructed from concrete pipe due to regulations. This is a very standard design for stormwater conveyance. And then for this particular road, everything will be drained to the low point in the south location where it would be connecting with stormwater management for the full subdivision. My second and third alternatives are open channels along the sides of the road. These are still within the right-of-way, and because they follow the topography of the road, there are currently 2 low points where the flow divides, and then at those 2 low points, they will then be connected to the stormwater management for the subdivision later on. So the second alternative is a concrete channel. It is trapezoidal in shape to maintain hydraulic capacity, and then it is concrete along the whole sides, and it has a 2-foot bottom width and 2-to-1 vertical or horizontal to vertical side slopes. The third alternative is a vegetated swale. This has a similar shape to the concrete channel, but has gentler slopes for regulation purposes, and it will have native vegetation along the bottom width. What I looked at for my conveyance alternatives is construction cost, adaptability, constructability, lifetime, maintenance, use of land, and aesthetics. So for construction, vegetative swales are the most cost effective because you're only paying for the excavation for the shape of the channel as well as planting of your seeds. Sewer piping has the most adaptability because it is standard design for stormwater, and it is also able to handle much wider ranges of stormwater runoff compared to the other two alternatives. Concrete channels and vegetated soils have a similar constructability score because you are only excavating part of the land, while sewer piping, there is significant excavation because you have to install the pipes deeper in the ground under the road. Sewer piping has the longest lifetime. Concrete has a lifetime of about 50 to 100 years, and while the concrete channel is concrete, it's exposed to more weathering and corrosion in the natural environment. The sewer piping and concrete channels have similar maintenance, while the vegetated swale has the most maintenance requirements because reseeding needs to be done to maintain the capacity of the swale. The sewer piping uses the least amount of land. There is no surface land being used besides the manholes, so it is completely under the ground. And then for aesthetic purposes, vegetative swales are the most aesthetic, while sewer piping, you're not seeing it at all, so it's not really considered. And then the concrete channel is the least aesthetic. So overall, sewer piping had a high score of 97 points, and that will be the selected alternative moving forward with this project. So for my phase 2 work, I will be finalizing inlet placement when Leah has her road profile finalized. I will then be doing a full sewer design, which means finding connections to the inlets and the manholes and finalizing pipe sizes and slopes. I will then be modeling the system in PC Swim to check that the energy grade line and hydraulic grade lines are below any dangerous levels. I will now pass it off to our structural engineer. Thank you.
I'm Amadiki, and I'm the structural engineer here at Vectors Associates. I completed the task of deciding the building site location and the orientation of it, and I've come up with a few design alternatives for the mixed-use structure. My next steps were to develop a cost estimate and a design matrix rubric to then evaluate my alternatives and end up choosing the best option to continue the design process with. So here is the design rubric used to evaluate the alternatives. The parameters that were scored was the cost of construction, the aesthetic of the building, the feasibility of the materials to obtain, the frequency and cost of the maintenance required, and the environmental impact of the construction process. Each parameter was given a weight to show its importance. So for this rubric, the cost of construction is seen as the most significant, while the environmental impact is seen as the least significant. As Silvana mentioned, this alternative, even though it was eliminated before the design rubric was developed, it was a one-level steel structure with the purpose of industrial and office use. It was eliminated because it just took up too much land, which made it difficult for our water resources engineer to place enough BMPs within the parcel along with it. My first alternative is a two-level steel structure. Each level will be 20,000 square feet with the commercial use on the first floor and the office use on the second floor. It will be constructed of steel, which is considered simple to obtain, and the maintenance required is an average amount at a moderate cost. Here's the grid for the beams, girders, and columns for alternative 1. The beam depths will be about 15 to 20 inches because the beam lengths are either 30 or 40 feet. And then I'd like to point out that majority of the columns will be hidden within the interior walls of both levels, and this contributes as a plus for the aesthetic of the building. My next alternative is also a two-level structure, but this one is designed out of reinforced concrete. Each level will be 20,000 square feet again, but the difference is now that the first floor is commercial use and the second floor is residential use. Concrete is very feasible to obtain in the Crown Point area, and it only has some impact to the environment when constructing with concrete. Now the grid for the beams, girders, and columns looks different than alternative one because there's quite a few more columns here, which means some of the columns will not be hidden within the interior walls. This alternative received a low score for aesthetic because of this. And then I also just like to mention that the beam depths will be a minimum of 15 inches because all of the beam lengths are 20 feet. For the cost estimate, RS means square footage was used. This program was very useful, but it could only do one use at a time. Because of this, I found the cost of each floor separately and then added them together, which means that some items were counted twice, like the ground excavation or the roofing material. So these numbers down here are actually an overestimation, even though they look pretty precise. But the overestimation is consistent between both of them, so it is still a valid way to compare the construction costs of both alternatives. One can still confidently say that alternative one will be more cost effective to design and construct. Now here's the scoring for all the parameters of both alternatives. As you can see, alternative one wins in the categories of cost, aesthetic, and maintenance. The only parameter that alternative two wins in is feasibility. With this design rubric, I've come to the conclusion to continue the design process with alternative one. So my future work here at Vectors Associates is to start the phase 2 work, which includes the more specific designs of the foundation, beams, girders, floor and roof system, and the columns. And I will be doing all of this for the 2-level steel structure. Now I'll be handing it off to our water resources engineer.
All right, thank you, Emma. So the first thing I'd like to do is reiterate my scope. What are my design services trying to accomplish? So the first thing is I want to treat the water. We need to remove total suspended solids and remove a certain amount of nitrogen before we discharge it into the wetlands in the northeast corner. I also need to infiltrate 1 inch of runoff and control the volume of how much water I'm actually discharging from that site. So I decided to accomplish these things using 2 steps. The first step is what I discussed in my previous presentation. I decided to create 4 different land planning alternatives and choose which one yielded the smallest storage volume and the smallest water quality volume. That came out to look like this. I used Emma's 2-story structure placed in the middle of my site, which allows for a lot of room for BMPs to go around, and we have a parking lot and a detention basin in the northeast corner. Now my second stage is what I'm going to be discussing today, and this is discussing the different types of BMPs that I used on my site. I chose 6 different BMPs, 3 of them water quality volume, and 3 of them conveyance focused. So, my 3 water quality volume BMPs include the biofiltration system with the upturned elbow. This system expedites the nitrification process and removes nitrogen from the water. And the next alternative is the permeable pavement. And finally, the sand filter is a flow-through BMP, and these 2 focus on removing total suspended solids from that water quality volume. The second set of BMPs are more storage focused, storage and conveyance. So one of them is the vegetated swale, the other one is the vegetated filter strip, and the final one is the wet detention basin. All these 3 remove total suspended solids. Now, when I had these 6 BMPs, I decided to create 3 alternatives, placing those BMPs on that site that I created in my first presentation. So, before I get into describing these alternatives, I'd like to establish a few consistencies. So all these 3 sites use the same detention basin in the northeast corner. All of them assume that the water, no matter where it falls on the site, is going to flow into that detention basin. So this first alternative focuses on treating the nitrogen. So I don't use the permeable pavement here. Instead, I size the sand filter and the biofiltration system to each treat half of the water quality volume. This means that the biofiltration system is very large. It's sized for half that water quality volume. Therefore, it's going to be most effective in treating that nitrogen. My second alternative has an even distribution across the 3 water quality volume BMPs. So the permeable pavement in this northern part of the parking lot is going to treat 1/3 of that water quality volume. In addition, that sand filter and the biofiltration basin also treat another 1/3 and another 1/3 of that water quality volume. I also assume that the structure's downspouts flow into these BMPs. My final alternative focuses on the idea that treating water upstream is most effective in removing TSS and nitrogen. So, if we assume that the parking lot is the major source of the pollution, which it most likely is, you have cars that are going to create brake dust, and you have oil that's going to come off that parking lot. I want to front load my BMPs so that way I can treat that water right away. As you can see, the northern part of the parking lot is going to force water through the permeable pavement, and then through a vegetated filter strip, and finally a sand filter before it gets to the detention basin. In the southern portion, we're going to have permeable pavement, valve filtration, and finally a vegetated swale before it gets into that detention basin. And each of these is sized for permeable pavement accounts for half the water quality volume, and then biofiltration and the sand filter account each for a quarter of that volume. So how did I analyze all these alternatives? One of them was the construction costs. I used EPA standards to quantify my BMPs and size them and associate them with a respective cost. Next, I looked at TSS removal and nitrogen removal. So, like for instance, the first alternative had the largest nitrogen removal facility, therefore it's going to be weighted pretty generously with the nitrogen removal. Next, I looked at maintenance, and finally I looked at more qualitative aspects such as how do these things look to the public and do they pose a safety risk. So let's see how these numbers graded out. So the third alternative ended up being the cheapest or the most cost effective, because each one of those water quality volume BMPs was sized smaller than the previous alternatives because there were more of them. And they all performed pretty well with total suspended solids removal. Alternative 1 was the best in nitrogen removal, like I said. And I would say maintenance, I quantified those. And safety, risk, and aesthetic, again, more qualitative. So if they were hidden from the public, they scored a better aesthetic score. So this turned out to be more favorable for alternative number 3. So it scored the highest, and that is going to be my preferred alternative moving forward into next semester's work. So what does that look like? I'm going to be selecting materials for those actual BMPs. So what kind of aggregates am I going to use? Are they going to drain well or not? And then I'm going to also do some more geometric designs for these BMPs. And finally, I'm going to evaluate the system as a whole. There might be some water routing because those permeable pavement spots might fill up first, and then water's going to flow through that swale and then into those other flow-through BMPs. All right, thank you guys for listening to today's progress presentation. I would now like to open the floor for questions. Yes.
Okay. Start maybe with, in the same order you guys presented there. I appreciate the 10 seconds between level B and C in there. My question will be, did you do an overall assessment over the design life of that intersection for whatever that design life, let's say 20 years or so? What will be the difference in terms of, let's say, the cost associated with those individual 10 seconds of time saving?
Yeah, are you referring to like the maintenance and
Well,
things like that, or?
I'm referring to what we call life cycle analysis, like
Okay.
the financial life cycle analysis of, so yes, I will be saving as an individual like 10 seconds by moving faster, but what will be the overall cost impact of having that alternative implemented compared to the other alternative?
Yeah, good question. I only did an alternative analysis based on like the initial cost of it, but my last presentation I went over how I projected all my data to be when the whole lot was developed, so when all 51 acres of land were being used. So I did not take into account like the lifetime cost, no.
Well, I'm looking at just the intersection.
It's just the intersection?
Yeah.
Yeah, I modeled the intersection, like, so let's say everything's developed in 12 years, then in 12 years, the intersection will run with a level of service of C with alternative separation, and that's like at max capacity. So when it's fully developed, the whole land, that intersection will have a maximum of 10 more seconds than other things. That's assuming that all 52 acres are developed. Assuming that some of it will probably not be developed because some of it will be like, I'm gonna assume like some water resources work and environmental work and things like that. But for the actual intersection, I did not take into account like the lifetime maintenance costs, no.
Good. Maddie, when you were looking at those different alternatives, and it seems you are migrating towards like swales, vegetated swales in there, did you take the cost of land? Think of the owner, I am the owner in this case, so in there, if I am to be giving, you should like 8.5 feet twice, plus the right of, or plus the width of the 2 lanes of the road. Are you taking more land, in other words, as you using, and I know finally you selected the concrete sewer lines, which is maybe be rejected by the town, by the city, because they don't consider that best management practice, or LID, low impact development in there. But in your cost analysis, did you consider the cost of land, or I'm gonna connect that to Leah's in there. If it's within the right-of-way, does the right-of-way change, right-of-way width change if you decide to go with like swales versus like sewer lines?
So because of the standard section that we had used for it, it's within the standard section right of way. So there's about 8.5 feet between the sidewalk and between the curb of the pavement. So it doesn't change the standard right of way width. So there's no additional land that's being used in terms of cost, but I did not consider additional land because of that when I did my cost estimates.
Good. So we could go with the swales. Why did you decide to go with the concrete sewer lines?
You told me to.
Because the city requires that, correct? Okay. Okay. And then, I think who's next? Emma? And I know I gotta stop before that. I don't know if I captured this correctly, but you said you're limiting the depth of the W sections, the beams, to 12 to 15 inches.
Yeah, those are the minimum. So it's just looking forward to next year, I'll be able to like specifically pick out the W beam, but those are just the minimum that is right now, like the rule of thumb that I found.
Ooh, okay. Well, that changes my question in there, because I thought you are dealing with 30 to 40 feet length, and then I thought the limit is like 15 inches, and I forgot my manual. So will you be able to get like a 40-foot W section with 12 inches depth? I think that was the original question, now I can change it. Are there like a 40-foot W section that is 12 inches deep?
I believe so, but I'll have to look more into it. I think not really, no, probably not. I think.
So when you say the minimum 12 to, what was in the back of your head, what was the consideration? Why you want to limit that minimum to, let's say, 12 inches?
Well, the rule of thumb was like the length
You're
divided.
talking about the depth.
Yeah, the rule of thumb was like take the length of it and then if you divide by 2 and then put that in inches. So like if it's 40 feet, it would actually like the minimum was 20. So I think I said 15 to 20 inches.
So, well, go back to this. Why you want to limit, why you want to put a limit, minimum, on the lower limit on the depth? What's the reason? I'm trying to go after the understanding of why do you want to limit it to say I cannot go below, I cannot go like 8 inches or like 6 inch like W section.
Oh, because it has to be able to hold all the loadings. It has to be thick enough to hold all the loadings.
Okay, I'll leave it there.
So I have a couple questions. So one for Leah. So in your intersection design, for the one that doesn't look as good, you have the encroachment, right, onto the
Yeah.
properties. Would there be a way to shift the intersection up, so maybe you're only making 2 people mad, maybe the property owners on the 2 properties
Yeah, so you're talking like taking these north, so like
Yeah, so
shifting
kinda
this like line
shift.
up. That was an idea I've thought about. I didn't draw it like that, but it was an idea that I had considered specifically since like this parking lot seems a little bit more used than this one looks. I mean, this one to me looks kind of like a junkyard from Google Maps. I don't know if that's what it actually is, but I think this land would be easier to acquire than like this building. So that is an idea. But I still think like the percentage of land that we would take right here would be greater than the percentage of land that we would take right here if we moved this one up. Because this land right here is ours still. So. I did not draw it like that, because I did not like calculate the exact area of land like taken over. It was more of like a, well, more lanes made me more land. It was kind of like a point A to point B kind of deal, so.
Let's do it. Well, it's always better to make just two people mad than
Oh, I agree, yeah, yeah, less people mad is always the goal.
okay, so at least less people. So, we're going to get it right way. So also on the, let's say, so for Todd, so on the
Yeah.
detention basin, it's kind of tucked in the site that you're developing. Would there be any benefit to look at kind of like almost making it like on the corner of the site so that it becomes like 4 parcels would then have like a
Oh, I see
detention
what you're saying.
basin?
So
Something
putting
like
it
that, thinking-
outside so it shares with other parcels.
Yeah, or just anticipating that maybe there would be like adjacent parcels that would be. in
So
that.
for
I don't
my
know if
study-
that's in your scope or not.
Yeah. For my study, I focused mainly on just my parcel, but if I was considering neighbors' parcels, then I think that would be very beneficial. But for my studies, I was just focusing on the parcel, so.
So,
I wanted to talk about the typical section of the roadway. We didn't see it, so you have a lane, maybe there's a shoulder, I'm not sure, curb and gutter. I don't know if there's a median and a sidewalk, and that's it?
Yeah, so we have 12-foot lanes at a 2% slope, and then the shoulders and like curb is all in direct like correspondence with the technical standards of Crown Point. But as Maddie kind of said, there's 8 to 9 feet between like the edge of like the aggregate on the side of the road to the sidewalk, and then after that, there's still like 2 feet if I remember correctly. It's
I don't remember.
there still is a little bit on the other side of the sidewalk though. I can't remember the exact measurements off the top of my head.
I guess what I'm, and I think maybe you started mentioning this, was if there is a ditch, whether it be paved or not, that adds a whole lot more space on either side. And I don't know if that cost was included in your estimates of taking that much more land. You know, you said, I think you said it was like an 8-foot bottom and 2-to-1 slopes, you know, that could be huge.
Yeah.
You know, that could be 12, 15 feet wide of ditch that, I don't know if you, that would cost a lot. Even if it's your property, it's property you can't now sell to someone to develop, so I don't know if that cost was in there. That seems to me that would have thrown that alternative out a long time ago. Anyway, every year I have this problem with people on their ditches, because they show a bottom and a 2-to-1 slope, but that means it's fixed, which means if your road goes up and then it goes down, then you know, how are you directing water in one direction or another? You know, sometimes they have to get deeper and that kind of thing. Anyway, the intersection at the bottom is the only intersection that's in your scope?
Yes,
The other 2 are not?
the other 2 are not in my scope.
Included, okay. How long is your roadway?
My roadway is just under 2,000 feet.
2,000 feet, so that's
about half a mile
less than
about.
half a mile, so
Yeah.
that's $28 million a mile.
Yeah,
Interstates for that. You might want to revisit some of that cost, I think, that's,
these were the, on my cost analysis, I did take the high, like the the higher average of the pay items from NDOT. So this is an overestimate, hopefully. And by direction of like my advisor, Professor Grossman, we decided to like do like lump sum for some of the costs of like lighting and things like that.
Right, right. At this point, you don't know what the
Yeah.
lighting's gonna be. I agree with that. But it sounds pretty high, so I think we need to
Okay.
perhaps look at that a little bit more.
What would be a good cost or a half mile?
For a half mile, I don't know, 5 million? Maybe.
Are we like, are we talking like 5 million like interstate? Cause or like,
You know, I've designed interstates and highways from the 70s to the 2020s, whatever, and the cost has risen. You know, it used to be you could get a mile for $1 million, six lanes. You know, that of course goes crazy, you know.
really crazy, yeah.
And now I think it's like $6 or $7 million per lane mile. So, but that's interstate standards and your pavement's a lot bigger and all that kind of stuff. So I don't know, it seems high to me.
Okay.
But we'll talk about that again.
Yeah, because also just to comment, it's all in that one line, right? It's all in your compacted stone.
Yeah, the compacted stone is very,
So
so that's what I figured out. That one seemed very confusing to me. The
Yeah,
sidewalk standards and the technical standards for Crown Point seemed very extreme compared to like the NDOT ones. So that is something I think in my like phase 2 work, it was to like do sidewalk design, because I do believe I will be substituting like NDOT standards over Crown Point standards in that, just for cost, because.
Yeah, I can't imagine that numbers, right?
Yeah, I mean, I just thought it was like 4 inches of concrete and then 6 inches of compacted stones underneath seemed very, it did not seem 100% right to me for,
Certainly the roadway would cost more than the sidewalk.
I
Yeah,
believe,
that's-
yeah.
that's the
That's
other
where
one. So-
I found the same,
I
I
think
looked at the numbers and I was
I
like.
think you just need to revisit that. We'll move on. Well, I guess I'm done.
Okay, so Leah, when you talk about the 20-second delay and 30-second delay, and all, is that an average? Is that during the peak traffic time, or?
Yeah, that's last progress report, it was like the 15-hour peak in the PM. So
Okay.
we're assuming that this is a like commercial business park, but like with like offices and stuff, so we assume that like, you know, the heaviest hour will be when the stores close and everyone's going home to eat dinner. And so that'd be like, I think it was like 27 seconds and then like 21 or 19 seconds, something like that. So that's like at peak time, but I think if you're on like, just driving by at like 9 AM, you might be pretty good,
Yeah.
not with 30 seconds, but yeah.
Okay, thanks. And then Maddie, you said you're using PC Swim?
Yes.
That's a commercial package, right? And it's, I think, it's fairly expensive, so
It was free to me.
how did you, how did you get it?
Vic Cole.
What's that?
Vic Cole. He down.
Oh.
Ajay has a license for
Ah.
it.
Okay. How did you get a license?
They give it free to students, you can use it in
Oh,
your class.
oh,
You
okay.
can get 30 copies for your classroom
Okay.
for academic use.
Okay. Emma, you mentioned that there are impacts of constructing with concrete. But what are they? Like, can you give some examples?
Just like the runoff,
Okay, that's what I was wondering if there's other things, but, yeah,
that was the main one I found.
okay, okay.
May I make a comment, or a question actually, just final?
Okay.
Because I'm still, and this goes back to between Maddie and Leah in there. What is the standard right of way for the type of road you selected? Because that could solve the problem of the price of land if by law, by the ordinance, City of Crown Point ordinance, say for this type of, let's call it residential road or whatever, that the right of way will be 60 feet.
Yeah, actually, that's exactly what it is. For a local road, which is what we're designing for, the total right of way is 60 feet in width. So, and from there, the Crown Point's technical standards has it like broken down into like 12-foot lanes, so many feet shoulders, and it's all dependent on if it's a like local road or arterial or collector, and we're designing this for a local road.
Okay. And so there are no issues for buying land, it doesn't matter what you decide to put in there, like a ditch, a swale, vegetated, unvegetated, or so on.
Yeah, Maddie and I kind of talked, like the land's already acquired, so we might as well fill it, so we're trying to work within that right away.
Okay.
Okay, so Todd, I got
Yes.
some questions. So you're using sand filters and swales, right? But those don't really do much for infiltration?
Mhm.
So are you still gonna be able to infiltrate 1 inch of runoff?
I think so. With my third alternative, there's the permeable pavement,
Okay,
and that digs down 5 feet into the ground,
okay,
and then you can fill it with like I think 60% voided rocks or aggregates, and I think that that's where I'm going to get most of my infiltration, because the site itself, if we looked at the soil report, it was hydrologic soil group C to D, which does not infiltrate very much.
Yeah.
So I just assume that if I'm going to infiltrate something, might as well dig down and create
Yeah.
void space in
Okay.
the ground.
typically it's 40% voids.
Oh yeah, I think, yeah, 60%, and then minus 100, yeah, 40.
Okay.
That's mixing in my head.
And so is that 1 inch per impervious area or for the whole parcel?
The
Remember?
scope outlines it as 1 inch of runoff, or I think 1 inch of runoff is infiltrate, I believe it would be the impervious area.
Okay. Yeah, thanks. And then you mentioned that you quantified maintenance when you did your assessment.
I did, I attempted to, yeah.
Could you, how did you do that, or what did you?
The EPA has a lot of pamphlets,
Uh-huh.
and if you kind of dig into them to get into their sources, a lot of the, so, where are we? Actually, I don't think it's on here, it's in my report, however. A lot of them will say something like, the average maintenance cost was $10,000 for if you treated this amount of acres of impervious area with this facility. And so using that, I was saying, okay, what's the impervious area of the site? And how much of that water is probably gonna get into this facility? And then from that, I created, it was like $5,000, $10,000
Okay.
around there. So
Okay.
there's a lot of estimations, but it's
Yeah, that's what you gotta do.
just what I, yeah, just
Okay,
what I did.
thanks. And then I think last question. It's my last question. I don't know if anybody else has questions, so.
I'm waiting for you to finish.
Okay. But, so I know you like got your alternative, and what, alternative 3, I think? What?
Yeah, it was alternative.
Did you consider parts of other alternatives that might work well, you know, just because it was in the first alternative and overall that alternative didn't score very well, there might be something really valuable in there that you could use in it?
Yeah, I think the biggest thing I was considering was my nitrogen removal efficiency,
Yeah.
because my third alternative does have the smallest biofiltration system.
Mhm.
So maybe potentially I could look into resizing it, so the biofiltration system here could take a greater percentage of that water quality volume, and then maybe make a smaller sand filter. Because that's one of the things I really liked about this first alternative, is because it's such a large biofiltration basin, and so probably the best removal efficiency there. Yeah.
Okay, thanks.
I didn't ask you a question before, but you just mentioned like C and D. Can you tell me which one you're gonna use in your like TR55?
Oh, I'll be using, I think D, because it's more conservative.
Is it?
Yeah, because it infiltrates less water, so if we assume that there's more on the surface.
How do you make that random decision?
I wouldn't say it's random. We're just gonna, it's better to over-design something, so that way we assume for more water on the surface.
Like, let's say scientific, so when do you decide to use C versus D in this case?
When do I decide to use it?
Yeah. What's the difference?
C would infiltrate
Why do
more
they
water.
give you C/D?
A C/D?
Yeah.
It's the estimation that the Soil Conservation Service came up with.
Why C/D versus like just A, B, or C and D?
Maybe it's half and half.
You wanna look at Professor Y.C.
Yeah, that's something
It is for
I'll
like
look into.
Drain versus undrained.
Yes,
So
the
if you
drain
put a
tile and
drainage
this-
sy- If you
yeah.
put a drainage system, then you can use the
Okay,
C versus the D, which is the undrained soil.
okay, thank you.
Yep.
Okay,